automated for something where humans were required earlier. Now you can reduce that grunt work by getting computer to do that particular thing, by writing the code that does this. Eventually, the value from computers comes if you are able to do things that people will be able to pay money for, right? Build real world
Yeah.
applications. For example, everyone knows operating systems, but on that, if Facebook was not there would not have been the monetization, or there would not have been the revenue that comes there. Here comes all of the specializations. Here comes all of the things like back-end engineering, front-end engineering, things like machine learning engineering, things like blockchain development, cyber security. All of them are doing what? All of them are at the end using these computer science skills to be able to create things that add value to people's lives, create things that people will be ready to pay money for, build things basically which helps economy grow and do all of these things, right? So high level, I will say that don't think of computer science as just the second thing. Many people unfortunately do that because that sounds cool. That okay, I want to be an AI engineer, I want to be an ML engineer. But equally important part is to know the first computer system fundamentals. Because I mean, as all of you say, right, that probably when you are building a very big building, the coolest part is when you see that floors are coming up. But actually, that building would not have been able to be that sorted if the time would not have been spent in building the foundation of that building, right?
Correct.
Are equally important. Spend time in both. If you have good computer science foundational concepts, you will have a much longer career in engineering. Will be able to probably go up to the highest levels like CTOs, etc. Yeah.
Great. Yash, your thoughts to be able to add that in terms of being able to kind of do that interplay with now with AI coming into the picture, what do students who study computer science have to look forward to with that?
Yeah, I think there is a very strong preconceived notion out there that AI is coming to replace computer scientists and developers, right?
Yeah.
And that sort of brings a lot of like people who perceive computer science, right? Like they have struggled a lot. They study a lot, right? Like maths, be it like principles, data structures, algorithms, development. They've spent a lot of time in honing their craft. And then you hear things like, okay, I think Devin or like someone is coming in and essentially now doing a lot of my job, right? So what happens to me, right? Like what about my skills? And that's where I think want to bust the myth, right? Where essentially what AI is, AI will never take away jobs of the top 5% or top 10% talent, right? Like who are essentially working, figuring out a lot of uncharted territories and navigating through a lot of complexities on their own, right? That's
Right.
something which AI won't do. But what AI will do, if today navigating through this complexity takes me maybe 1,000 hours or 5,000 hours, with AI, I can probably do it in like 1/28th or 1/30th timeline, right? So it
Right.
enables me to become more efficient as a developer than taking away my job altogether, fundamentally. So rather than becoming someone who hates AI, does not fear, like rather fears AI or like is threatened by AI, the future of computer science or future of all developers is uh, integrating with AI, right? Integrate your lives with AI. Potentially, we use AI, chat GPT on our day-to-day lives, right? How do I integrate AI in my workflows? How do I integrate AI while coding, right? How do I integrate AI while testing my code or putting it out there, right? That's fundamentally how we see AI to be implemented and leveraged at scale.
Wonderful. Okay, great. That gives me a lot of perspective. So, if we're looking at computer science, we're looking at it from the perspective of this is the foundation that you're building your house on. Then, where we're looking the foundation to go forward on would be specializations that I'd go into or areas that I'm going to now develop on, which is my terrace and my other areas that I'm building, which is my artificial intelligence and all of the new areas that are coming in. But the foundation remains strong for me to be able to have to build to be continue to build those. We hear from a lot of students where they come back and they say, I want to get into data science. I want to get into cyber security. I want to get into these spaces. So when we're looking at these specializations within computer science, what are some of the new things that you would like to be able to give as advice to students who are looking at spaces of cybersecurity or data science, or maybe looking at something like software engineering? Because I think with a lot of students, what happens is there's a lot of interchange in terms of how they make it almost like a replaceable terms for each other, and that ends up causing confusion in their own minds when they're learning, right? So, Naman, first your thoughts, and then Yash, please after that, if you could also share. So, what happens for a lot of students is they come and they're interchanging, and I'm like, no, wait, hold on, I'm confused as well. What are you actually looking at? So, yeah, your thoughts.
Right. I think great question, Shilpa. I mean, thanks for that. right? I mean, unfortunately, what happens is a lot of us, right, build our perspectives by seeing what comes in the news around us, by seeing
Right.
what comes on our feed, right? And unfortunately, how algorithms work is the cooler things come there, right? So the things that are actually probably not so cool, but probably are the base of a lot of things, they do get missed out, right? I think I myself have been a victim of that. I think when I started my computer science degree, after 1 year, I moved into data science. Okay. And then I decided, I in fact ended up doing an internship, etc., in data science, ML engineering. Then I decided to come back into software engineering and went ahead, right? So let me probably talk about uh, what or how you should, or how one should think around specializations, how one should make a particular decision, right? So let us try to think from the perspectives of maybe the top tier companies that all of people will eventually want to go into after probably having done a degree. Right? For example, companies like Google's, companies like Facebook's, etc. Right? None of these companies actually hire like a machine learning engineer, or they will not hire like a cybersecurity engineer, or they will not hire
Okay.
a ops engineer. Okay. Most of these companies will hire a software engineer, comma something. Okay. For example, at Facebook or at Google, there will not be a title machine learning engineer, or there will not be a title data engineer. The title will be software engineer data, software engineer machine learning. Now,
Okay.
sorry, I think I'm just a bit sneezing, but yeah, I think the reason for that is because at the end, all of these specializations are an extension to a software engineering skill. If
Got
you're
it.
a software engineer, what you basically mean or what you basically know is how to use computers to be able to get something done. That okay, I know that okay, if I have to get a computer to print something, this is how I will do that. If I need to get a computer to iterate over a set of items and get some information out of it, I will be able to do that, right? Now, this thing, if I want to do in machine learning, because at the end foundations are same, then I start specializing or I start adding niche skills of machine learning into my domain so that I can also get into software engineering machine learning roles. Similarly, if
Got
I'm
it.
excited about data pipelines, I will start getting those niche skills, but the foundational ones will remain the same. Okay. Now, what is this foundational skills evaluated upon? I think Yash, when he was speaking, he highlighted things like data structures, algorithms. I in the previous question had highlighted things like operating systems, computer networks, right? These are the skills that are going to be asked for you in whatever kind of specialization that you are going to go to. Okay, be it data science, be it data engineering, be it ML engineering, be it a backend development or a front-end development. Why so?
Okay.
I think the three ones, the computer science operating systems, computer networks, database management systems, I talked about that earlier, right? Because these are the things that all of us are using around us, right? If you don't even know them, you probably will not be able to build good systems, right? Then the next one is data structures and algorithms. What is data structure and algorithms? If you see people, for example, appear for UPSC exams, people appear
Yeah.
for CAT, people appear in school days, NTSC, right? In all of these exams, there is one kind of question that is very important. I mean, anyone, any guesses? Maybe in the chat. What
Yeah.
kind
Actually, good idea. Let's ask them. What kind of questions are one kind of question is very important. Okay.
is very common in all of these? Be it you appear in UPSC, be it you appear in CAT exam for MBA, be it you will appear for NTSC. Logical reason.
Logical reasoning,
Problems.
problem solving.
Correct. Now, why so? I mean, why did they ask questions about problem solving? I mean, in UPSC, you're probably not going to find those patterns, but why did they ask them, right? Because at the end, all of these skills are a proxy of how good of a thinker you are, how
Got
smart
it.
person you are, how your brain figures out patterns, right?
Yeah. Yeah.
Data structures and algorithms are exactly the same in computer science. DSA is basically having a thinking that, okay, I'm given a real world problem statement. How can I use some knowledge that I have to solve a
Hmm.
problem? What kind of algorithm, what kind of steps I can do to solve that problem in a way that can be done by a code, that can be done in an automatic way. They are basically a proxy of your being smart, of you being a good learner. That is why at any of these companies, the top companies that you might want to aim for, they will have all of their interviews around data structures, algorithms, operating systems, computer networks. So my advice to all will be probably in the very first 2 years of your college, when probably we are younger. At that particular time, actually building a ML model sounds very cool. Building a website that I can show off to my parents sounds very cool. But probably hold off the things for some time. Probably use the first 2 years to build the foundation in these three, four things. These are a bit boring, so as to say. But as I mentioned, when you are making a large building, a building that has to stand career of 40 years, It's fine if the not so cool part of creating the foundation happens for the first 2 years. It's perfectly fine to do that. Spend first 2 years building a very solid understanding of these things, because if that is very strong, later on, whatever domain you want to go into, be it backend, be it full stack, be it front end, be it MERN stack, be it ML engineering, all of those will open up for you. Then from the third year or so, start gaining one of the specialization. In these 2 years, you will also kind of get to understand about you. Do I like building front ends? Do I like doing things into machine learning? Then start specializing into that. This will be probably the best way for you to get
Yeah.
into a top kind of companies, in my opinion. Yeah.
Yeah, no, makes sense. And I like the fact that you're talking about being able to look at learning the basics better and
Yeah.
then being able to decide what you want to jump into instead of being able to pick something in advance. But Yash, your thoughts on this? I would love to be able to hear your thoughts as well
I
on
think
this.
quite a few similar thoughts and quite different perspectives also, right?
Yes,
One
please.
thing I agree a lot is with Naman is that the way we today decide our career trajectory or career options or even academic options, right, are based on largely dependent on public optics, right? What is the public perception of this qualification, right? We look at that key, what are
True.
my neighbors doing, or what are, like, in general, wisdom of the crowd is something fundamentally try to rely on while making a decision for very specific to our child or like for ourselves, right? Like, and that's something which is happening since centuries. It's not something very new also, and we have, I think it's time to change that, but it's been happening.
Yeah,
Right.
true.
And the second approach we take is now a very recently, now that we have become very commercial and commoditized and fundamental in a way we think, we backwork from the CTC, which is, I think, the worst possible way to look at it, right? I want to do a job which pays the highest. I don't know whether I have the skill set for that, whether I have interest in that, but that job pays highest, so I should prepare for that job. And that's why this is the qualification I require. So
Yeah,
that's how,
you're talking about something that bothers me a great deal. A lot of students will come and ask us, we hear there's a lot of money in software, or the fact that if we become getting into computer science or software engineering where there's lots of money, whether it fits or not is a separate story. But yeah, I'm glad you brought that up. Thank you
yeah.
for bringing that up.
And I think the way I approach, right, I don't come from a technical background. I went to business schools, right, but again built a couple of AI companies, managed engineers, right. So the way I looked at it was that essentially technology is a commodity, right,
Yeah,
used to solve problems. So figure out what problems are you passionate to solve about. Are you passionate to solve problems for other websites? Like Google has some glitches and errors. Are you passionate about identifying those bugs and errors? Right? And then you essentially end up foraying into the world of bounty hunting and essentially in the world of cyber security, or very broadly spoken, right?
correct.
If you are too passionate about playing around with data, manipulating data, then you essentially look at like a data science as a field somewhere, right? So essentially, what I would recommend every student or even parents to look at, right? What are your child? What kind of problem statement drives your child, or what kind of a problem statement as a aspirant you are passionate about, right? To solve, and essentially, then you just plug technology, and you will actually find your direction the same way, right? When you try to deep down on how this problem is being solved currently manually, and then how technology comes in, then what is the tech stack required to solve for something like this, and what I need to learn. So that
Right.
is sort of a way where you backwork the entire thought, like thinking pattern on how I what I should learn, because there are literally, I think, 30, 40 odd different languages, if I'm not wrong, like taking from Kotlin to .NET, the most legacy languages, to Next.js, which is like one of the most upcoming and like highly used languages now after React, right? Uh, the world is endless and it's going to keep growing. It will become infinite, right? And the options in AI models are also right now 5 to 10 big ones, which we all know of.
Right.
So to exactly know what you want to do, you first need to identify the problem and the tasks and the utility you are passionate about.
Yeah,
And
no, great. I
that's
like that. And
basically,
I'm very glad that you both brought that up. That one, first understand where you're at, then be able to look at what you want to get passionate about. I want to ask a segue question here to both of you. A lot of students will come and be wanting to know things like what are the kind of languages they can learn, what are the things they can work on now in school, or already start and set the foundation sort of a thing. Now, in my exposure in corporate, and I know I am dating myself massively when I do this, obviously there is the whole Java, C++, and then Python and all that. And then I heard Ruby on Rails and I was like, oh my God, what is Ruby on Rails? And I was very fascinated, but I know that was probably many thousands of years ago when it comes to computer languages. But as a student in my 11th or 12th, what are some of the things that I can learn or set the foundation for, which will maybe make my entry into a computer science program or a software engineering program slightly smoother? Is there an advice you can give students on something like that?
Sure. I think let me take that up. Sorry, I just wanted to actually clarify the question a bit. You are asking that if I want to enter computer science education, maybe probably I
Yeah,
want
I know
to.
I want to pursue the degree.
Okay.
I'm preparing myself for it and
Mhm.
I'm doing all the things that I can. What are some of the things that I can do to sort of supplement myself or prepare myself better, where I can stuff that I know I can do on my own, where I might not need a traditional classroom kind of a thing? Is that recommended even? Do you
Sure.
think it should be done? If there is, what should it be? I mean, I'm just throwing that in there.
Definitely. I think a very good question. And something that I also relate to. I mean, probably after I had completed the boards before the college was about to start, there's a lot of curiosity, right? What can I do at this particular time? Or when I'm completely, let us say, ready for the college admission, right? I think in computer science, there is another part of computer science which is called computational thinking. Okay. So while coding, programming, etc., is a part of applying that particular thing, but a strong foundation to that, which is having a computational thinking mindset, a mindset that thinks the way computer does. For example, one very basic thing, but one very basic difference between a computer versus a human is that a human can fill in the gaps. For example, if I ask you that, hey, can you please do this thing for me? Even if
Yeah.
I'm not completely clear, you will assume some things, you will fill the gap and you will probably get the thing done. But a computer does not work that way. Computer has to be given exact instructions, to the point instructions, even if those instructions are boring, right? That is a development of computational thinking mindset. Then there are some other parts also that come to it. For example, in computer science, there are things like recursion, there are things like stacks that if you know about, when you start coding, when you start learning things, probably you will have a much better experience. So I will recommend, if you can, before you start your formal computer science degree, maybe do a course that helps you develop computational thinking. Okay, there are many,
Okay.
for example, courses that are available even on internet. For example, MIT's free course. There is a free course by MIT which is Introduction to Computational Thinking with Python. So it's a very basic Python
Perfect.
course,
Okay.
Python well, but that is one thing that you can try to do. Similarly, Harvard has a CS50. Maybe to try some things like that.
All right, wonderful. Thank you. That helps a lot. I mean, so basically, what we do is set the foundation in computational thinking and basically problem solving. That will be your best bet to be able to go in
Yeah.
and be able to look at that. Great. In terms of career opportunities to graduates, what do you think in terms of the expected demand that's going to be there over the next few years and in the coming years? What are some of the areas that are actually going to be growing spaces, so to speak, because that's the most common thing we get asked as well. I would love to have your insight. So I'd request Yash to be able to weigh in on that from your perspective, and then Naman after that, if you could weigh in, please.
Right. So, from a career opportunities perspective, right? So let's just break down for the spectrum of computer science in two parts, right? There are two type of companies essentially. One is product-based companies, your Amazons, Ubers, Googles, Microsofts of the world, essentially, right? Or like Zepto, Zomato, which is like
Yeah,
essentially app. They build their own products and they're commercializing their own products,
got
right?
it.
These are product-based companies. Second are the type of companies which are service-based companies. They're essentially outsourcing partners to larger companies like a TCS, Wipro, Accenture kind of companies, right? Now the caliber requirement, the complexity of the job, and the uh, average pay for both these type of companies is vastly differed, right? Like for
Okay.
product-based companies like a Google, Microsoft, you will have the salaries are also, we know what salaries look like for these roles. We also understand that these are the most coveted jobs because these are highly selective in nature, right? The kind of intellectual capabilities, problem solving aptitude required for these roles is very high because you're looking at like you're firefighting almost every day. Imagine like millions of rides happening on Google every day, matching so many drivers to so many customers, then cancellations, then rebookings, then getting the locations right,
Oh,
right?
wow. Yeah,
There
no,
are
I
so
hadn't
many
thought of it
complex
that way.
problems.
Yeah, that'd be overwhelming. Yeah.
Exactly. So these are the kind of problems which product engineers in product-based companies solve, right? So by default, the caliber, the rigor, the capabilities are very different, and that's why it reflects on the pay grade. On the other hand, there are service-based companies. What we're not trying to say are not that these companies don't require you to have a caliber, but in these companies, largely you are doing you are a support function to someone, right? Because core technical proficiency organization always maintains internally, right? You are doing things which they internally don't want to spend time on is what you are getting, and that's why uh, the that's why all these service-based company like a TCS, Wipro, they have their own training schools for 6 months. They will probably take people who are like fresh out of college with limited skill set, and they'll groom you into those specific support functions for a longer period of time, right?
Yeah.
Now, definitely, service-based companies have way too many hiring requirements, right? In volumes. Fundamentally, we look at like lakhs of folks getting hired every year, while product-based companies Google might just come and say 100, 500,000 people a year. But these 1,000 people are potentially the best developers or computer science folks in India, right? So that's the first major difference what you see. Now
All
there
right.
are two school of thought. Now these are the type of companies you look at in career opportunities. Now in product-based companies or even service-based companies, the roles are essentially one is like your development role, which is essentially you are developing an app or a website or some kind of an software, I would say, right? Like you're looking at a front end, back end, or full stack, which is essentially both, right? And then you have roles like DevOps or SRE, if I'm not wrong, right, Naman? Where essentially you are scaling up systems. So today you have 1,000 users. Now you have to scale up to 100,000 millions of users. Now you need someone who can assist you in scaling your systems, right?
Yeah, got it.
Right. So that's essentially those kind of folks. And then also now today, if Zomato changes their platform completely tomorrow, very likely it's going to break down because people won't know how to navigate through that, right? Also, suddenly Zomato's size of users double down tomorrow. There is likely the platform will crash. That's why you have someone called as a quality assurance person who is ensuring that these systems are stress tested beforehand before they even go out there, right? So these are some of the largely prominent roles like which are in mass level. But if you still want to get into the top 1%, you're looking at very strong R&D type AI roles who are basically training these AI models like a cloud or a GPT or like folks who are essentially figuring out what's the future of technology, right? Things which don't exist today are probably working on those kind of projects, right? So this is the kind of a spectrum of computer science which you can evolve, and the best generation of folks, right? Founders who are like, okay, I'm not going to build for anybody else. I have the right skill set and I'm going to build for myself and build a potential unicorn.
Yeah. Okay. Very exciting spaces actually. Yeah, it's a very brave new world. Naman, your thoughts?
Yep, I think very much resonate to what Yash was saying. I think overall, one thing is that the existing domains, the existing most popular ones, recommended ones, like backend, front end, full stack, they have their own problem statement, right? So they are going to grow even further. I think their need will increase more and more. So don't think that, okay, while the new domains are coming in, the previous ones will go out. So backend, the need will keep on increasing because I think, as Yash was mentioning, as the number of users increase further, the need of people who can build such large scale systems will increase even further, right?
Right.
So backend engineering, front end engineering, for example, was seeing the website of Mindler. It's a very beautiful looking website, right? These days, people are very nitpicky about UX, seeing that a website is very good looking, that will attract good customers, right? So front end engineers, UX engineers will be needed a lot. Full stack developers, startups need a lot, right? Startups unfortunately don't have enough money to be able to hire separate backend people, separate front end people. So they will need people who bring in the complete holistic variety of skills. So they are also going to be a very important ones to have. Then the new ones like ML engineering. I mean, these days almost every company is starting to incorporate machine learning in their systems in one form or other, right? For example, even at Scalar, what we have done is a lot of parts of our system where we earlier used to need humans. Now we are able to automate that via GPT, taking up things. Chatbots these days are coming up a lot. So companies are
Yeah.
trying to deploy machine learning models in multiple forms, right? So ML engineering is also going to increase, is what I will say. Then another one is cybersecurity as computers become more and more vast, as the people who are probably not from the computer backgrounds, they also start using computers. Unfortunately, the attacks can increase. People who are probably not, I mean, not the good ones in the society, they will try to hack those accounts, try to leak money, etc. So need of cybersecurity engineers, etc., will also increase. So I think these are the domains that I do see a lot of potential in the months to come. Yep. In the years to come.
Wonderful. Wonderful. Thank you. That's a lot of new areas, very interesting and exciting times for computer science students and people getting into that space. At Scalar School of Technology, how is your computer science program and the programs that you offer different from the more traditional computer science programs that are out there, right? So I just want to be able to kind of get a little bit of an understanding of that. What are the differences? What are the things that are sort of the unique areas that you're offering at your institute as opposed to a traditional degree?
Yeah, I think like we all discussed right now, different career opportunities that exist right in today's space. What's more important to understand is how the market is evolving, right? Demand
Right.
is increasing, but supply is increasing tenfold. So today, in India, there are 16 lakh engineers who graduate every year, but only less than 2% of them are able to get jobs worth 8 lakhs and above CTC. That's the sad reality and sad state of today's Indian ecosystem. And the reason is today just being a developer, just having those basic foundational skills is not enough, right? Because a recruiter today on an average gets 10,000 resumes. At least at Google, the number isn't maybe add a zero. 1 lakh resumes recruiters are looking at for maybe 20 openings, right?
Yeah.
So today what matters is, can you show me a proof of your work, right? Okay, you are saying that you know JavaScript, React, or Python, but how do I trust you, right? How do I trust you? Trust your words and what you have written on that one piece of paper you called resume, right? And that's when proof of work is very important.
Got it.
Right?
Okay.
So proof of work can be in form of projects, any apps you have built, right? Anything which you can physically demonstrate or physically showcase, tangible project software which can showcase your ability, your competency, and your proficiency, right? And that's how Scalar School of Technology is very different. In our 4-year undergrad program, our entire philosophy of program is learning by doing,
Interesting.
right?
Okay.
Which essentially means, so our entire program is divided into 3 parts, right? Maybe if I can quickly show slides so for everyone to have a better
Sure, sure. Why not? I mean, and
representation.
that will
So I
help us
think
understand the curriculum a little bit better also.
absolutely
Perfect. So why don't you do that? That's wonderful.
perfect,
Yeah.
perfect. So I think to just give you a broad idea about our curriculum, right? So it's a 4-year program, right? One of its kind, where in first 24 months, the emphasis is on learn, right? In these 24 months, we essentially prepare students to become full stack developers, develop a very robust skill set while building projects. So if you ask me a day in a life of a SST student or Scalar School of Technology student, they start at 9 o'clock in the morning. They go through a learning session where they are taught, and not just by a faculty who's a PhD. While we have very high regards for PhD faculties, we believe that a true developer can only be taught by a developer. So all our faculties come from Amazon, Google, Microsoft, Snapdeal, all product-based companies. So every faculty of ours full-time is an ex-developer, has built respectable and reputable products at scale. Right? It's just like doctors can teach doctors, right? Uh, Same way a developer or a computer science leader can come and teach a
Correct.
future generation of computer science leaders. So that's
Yeah.
something which we look at in the first 24 months. In a normal traditional institution, what happens is first year, irrespective of your branch, is a foundation year, which means if you take computer science, you're still going to study 10 other subjects in the first year, which are absolutely not relevant to your goal, which is computer science, right? So essentially, what we have seen is students in normal traditional institutions, what they study in the third and the fourth year, they're essentially completing all that learning within the first 2 years with us. And they
Okay.
also have 20 to 30 very strong projects built in those first 2 years to demonstrate their abilities in their
Got
lab
it. Okay.
sessions, right? After that, the third year is the most unique part about our program. The third year is the internship year, where we say that, okay, now we believe that you're ready to go in the industry, not for 1, 2 months of summer internship where you absolutely learn nothing. But now you're ready to go into a year-long internship with one of our 900 odd partner companies. The number has just increased to 1,200 in the last 3 months because everyone is very curious to hire from us. In fact, today we had Google come on our campus for the pre-placement conversations. So we have on-campus placement assistance for students for these 12-month internships, right? Why do we provide these 12 months internship? Because there's no point in you just learning and building projects. You need to go in the industry. You need to work with people who are at least 10, 20 years older to you, learn office dynamics, work dynamics, working in teams,
Yeah.
contributing to some great products, right? And then once you come back from the third year, what we expect is students are more self-aware.
Hmm.
They are now aware about what skill set they have and they don't have, what type of problems they're excited about, they're not excited about.
Got
And
it.
that's how they go into the fourth year of the program, which is a specialization, right? So we have four specialization options. Again, two of them very unique to us. First is AI. Again, it's not a topic of AI. You won't study a GPT. You will study something very in depth, like a TensorFlow, build AI, comprehensive AI models, work on them. Uh, Job is not to teach you how to write ChatGPT prompts. It's actually to figure out how ChatGPT is built and build smaller and more niche models, right? In that 1 year, very
Yeah.
specifically focusing on AI. Then ML likewise. And the third and the most unique one, algorithmic trading. Now, for most of you don't know what algorithmic trading is, there are institutions called as hedge funds, quant
Yeah.
trading funds, right? They manage billions and billions of dollars of funds, right? And they have to earn return on that, right? So when we only put 1 lakh, 10 lakh, we are like if 1%, 2%. Now imagine deploying billions of dollars every day and generating an alpha or a return on that, right? So these folks built strategies using Python and other languages to be able to generate those returns, right? They're called quants. Now you won't believe all these packages we hear in the news, right? 1 crore package at an IIT or like 2 crore packages. These all packages are essentially given by these companies called quant funds or hedge funds, which are your Alpha Grep, Renaissance, Jane Street, Tower Research Capital. These are the most lucrative fund companies and funds, and we as SST are looking forward to attract these companies, and a lot of conversations are ongoing. And because we have these algo trading specialization for these students, right? We're probably one of the first institutions to introduce this because we believe that the kind of selectivity our students go through, right? The rigorous entrance test and the 2 rounds of interview, we will be able to adapt and attract the top tier students in our institution who can essentially succeed in these type of roles. And fourth is something called as advanced data structure and algorithms. So like Naman can definitely vouch for this. A company like Google has all 4 rounds of interview focusing on data structures and algorithms. So students who are very keen on only laser focused on companies like Google, Microsoft, Amazon,
Yeah.
they can spend an entire year mastering data structure and algorithms and developing that strong uh, computing thinking skills, which Naman was mentioning, right? So that they can not just get into these companies. The goal is not to help students get these jobs, but to how enable them to become great tech leaders 10 years, 15 years down the line, right? That's how we can build a very robust alumni base, right?
Very interesting. I like that. Now, I have a question for both of you. You
Yeah,
mentioned internships, very important, right?
yeah.
So, Naman, first for you, before you began your career in earnest in computer science, what were some of the misconceptions you had about the career? And if you did an internship, how did it help you? Or if you had gotten a chance to do internship, how do you think it would have been advantageous to you
Sure.
if that was there? And do you think it's a good idea for students to do internships even at the school level in different spaces to get a clearer understanding? So if you could share with me on that, please.
Sure, I think great question. Thanks for that. I think I will I will break it into two parts. The very first one was misconceptions, right?
Mm,
And then the second one, I will get into internships, the value of them, when to do that, etc. Starting with the one on misconceptions. I think one we briefly touched upon earlier, which is the misconception that probably being into these, I think directly starting into data science, etc., is the way to go. I later realized, okay, and that probably having had spent time building the foundation in the initial years, in the first or second year, would have been a better thing for me. In fact, I actually did talk to a lot of my friends who had been GSOC mentors, GSOC selectees, etc. They also later realized that eventually, if you have to get a better job, it is okay probably to spend the very first 1.5 years doing the boring things, but getting that strong foundational thing, and then starting to specialize into that. So I started with data science, then I later had to backtrack, learn those foundations, and then I started specializing into data engineering, etc. Right? So that is how I course corrected that later on. The
right.
second misconception I had was that the very first job outcome that you have decides what career trajectory will be taken. Actually, that is not true. For example,
Okay.
people think that okay, after college directly, if I'm able to not get into Google, etc., my career is now effective for the life, right? Or I mean, even bigger misconception, many people feel that, okay, if I'm not able to get into IITs, IIMs, etc., my career is messed up. I was not able to get into IIT. In fact, I was not able to even clear JEE main for that matter at that particular time. A lot of things happened. But what I realized was that it doesn't matter over a longer period, right? Your career, as I again say, it's not a 1 year thing, it's not a 2 year thing. You are here, you are going to be there in the industry for 40 years or so. Maybe college might impact you for the initial first few years, the initial first few opportunities that you might be getting. But if 10 years down the line, it is still your college affecting your career, I think probably you took multiple wrong things later down the line, you multiple
Fair point.
opportunities that you missed. So this was the second thing. I think despite of being at a tier 3 college, what I was able to get into directly after that was into Google. So it also says that probably software engineering is a lot democratic field. It's one of the fields where, as Yash was mentioning, proof of work. If you are able to demonstrate your work, software engineering is a domain which will be more than happy to welcome you. Regardless of what background you're coming from, you're coming from a career gap, you're coming from any kind of company, they will be more than happy to welcome you. So I think these are the two misconceptions that I wanted to clear. Second is internship. I think internships are definitely valuable. In fact, in my college, I did an internship after the first year as well. Okay. I actually did 3 internships over my college, and I think that is definitely valuable. Multiple reasons, right? The very first reason is it helps build your network. Okay.
Right.
You know people, and because software engineering industry is very well connected. In fact, as of today, I know so many people who, even if I was not working at the current job, would have been a second degree connection of me, right? This is so much how much connected the world is, right? People will move on to different kind of companies. If you do more interns, you know more people 5 years down the line, 10 years down the line, they will be spread around at different companies, at different places. Having that network helps you. Okay. So
Absolutely.
definitely I will very much recommend doing an internship. In fact, I will recommend if you can try to do an internship at an early or a mid-stage startup where you get to execute a lot at big companies, for example, companies like Google, etc. In the internship, you don't really get opportunity to that much implement things. I mean, having said that, if you do get an internship at those companies, by all means, go for that because experiencing the big corporates also is important. But
Yeah.
otherwise, you yourself have to scout for opportunities. Try to scout for opportunities in early or mid-stage startups because you will get to execute a lot and you will have get to build a lot. And the more you build, the more proof of work will get into your resume. And then, as Yash mentioned, and as I was mentioning already a few minutes ago, because software engineering is a democratic field, having that proof of work will remove all of the barriers of whatever kind of college are you coming from, whatever kind of CGPA you had in your 10th, whatever kind of percentage you had in your 12th, all of those barriers will be removed and you will be like any other person with a similar kind of experience.
Wonderful. Thank you. I think that's very important information you've given is A, look at the long run. It's a marathon, not a sprint. And be able to, course correct where you need to. And also the internships are valuable, primarily also from building that network, being able to grow your work as you go forward. Doing internships with things like places like startups. Actually, I firmly believe that no matter what area of work you're getting into that ecosystem is very important. You get to do a lot more hands-on work than you would otherwise. Um, so, Yash, specifically to you now, can you elaborate for the people who are online? What is the eligibility criteria that Scalar looks at?
Absolutely.
What subjects? What is it? Do I need to be good in mathematics and stats? What is the background? What is the process for me to be able to apply? What is it that has to happen if I want to apply for an undergrad program?
Definitely.
What do I need to look at? So, if you could give us
So I think
details on that.
most important thing we need to understand is how Scalar School of Technology as an ecosystem is, right? We are a very highly selective ecosystem. When we say that, the reason why we are very highly selective is Scalar as an institution is a 10-year like organization, is a 10-year-old organization, and we have over 5,000 plus alumni from a working professional program who are essentially senior leaders at Google, Microsoft, Apple, Flipkart, Amazon kind of companies, right? And the biggest USP or the unique proposition for the students is who are a part of our institution is that every student who gets selected at Scalar School of Technology is assigned one mentor from who is a very 5 to 6 or 10 years experience from this company
Oh,
throughout
good.
their journey for 4 years.
Oh, wow.
So
Okay.
throughout 4 years, you potentially will have a Flipkart senior software engineer as a mentor with you throughout your journey to help you address all your problems, all your confusions, navigate through challenges. And essentially, if you build a great rapport, potentially coming with a referral by the time you graduate, right? And I think that's one of the biggest USPs, right? And we also have a concept called super mentors, right? Super mentors are the ones who potentially come once in a week or once in a month, right, and visit. Uh, and these are not small folks. Like this is Rajan Anandan, right, who was the ex SVP or country head of Google India and the ex MD of Microsoft. Kunal Shah,
Yeah.
founders of Zomato, founders of Zepto, founders of Flipkart. They are the kind of folks. We also had founder of like Amod Malviya, who was the CTO of Flipkart, come in and take like a whole series of lectures with our students, right?
Nice.
So our entire program is very industry led, and that's why the kind of quality of students which we have is also very highly selective in nature. So to give you some numbers or insights on our students, right? This is what last year we had 54,000 registrations, out of which we found that 5,000 students were eligible. Now, for eligibility, we have two basic criteria. One is you need to be below the age of 20. And second is you need to have at least 16 maths in 12th grade to be even eligible to apply.
60.
Yes, 60
Okay.
in maths to be eligible to apply, right? So last year 5,000 students applied and we had 190 students who essentially we selected. So that's a 3.8% selection rate. Now this year, since I have joined in and I am very passionate about AI and like about a very strong sense of how the right talent pool looks like, we have gone even further lower down in selection rate. Our selection rate as of now looks at 1.8 or 2%.
Dude,
Right.
okay.
Yeah, and I'll tell you why, right? And I'll tell you, our students,
Making it tough for the kids to get in. Okay.
yeah, and I'll tell you why, because this is the kind of students we have, right? A lot of our students within first year have gone to ICPC regionals already, right? Within our first year. ICPC is essentially your Olympics of coding, world level. They have already been one of the top performers in regionals. Our students are already working with the government right now to build AI products. In fact, Narendra Modi, our Prime Minister, used our product Bhashini when he was giving speech in Karnataka for translation. So we have some very significant projects our students are contributing to. We had a gesture-based gaming system built by our students, uh, and we have different robotics lab innovation centers where they. Within first year, the founder of Zolo came on our campus to give internships to our students, and there are students who are already working on creating high impact products for those organizations.
Right.
So
Nice.
these are the kind of things which our students are essentially at such young 17, 18 building, right? So our selection criteria is very simple. We have an entrance test, right? Which is every month. It's called NCET, which is a national selection entrance test, fundamentally for Scalar School of Technology. In that NCET examination, we have 3 sections. Now we have a very strong philosophy. We only focus on things which are required, right? So we don't focus on physics and chemistry, which is not a part of our exam. So our sections are very focused on computer science. It's mathematics or quantitative aptitude. Second is your logical reasoning and data aptitude. And third is your learnability, which is the first time ever in India we have introduced a section called as learnability, where essentially within the exam we introduce student to a very new concept across subjects, and based on that subject we give them a question. Concept we give them a question. So
Can you give me an example of something like that you've done in the past?
yeah, so for example, we introduce student to a concept of linear regression, and then we
Okay.
ask a question on linear regression. So now student has to understand and grasp that concept and then apply that concept into a problem, right?
Interesting. Okay.
What we are trying to say is we want students with robust, strong foundations in mathematics and logical thinking, and we also want to see how fast you grasp things, because the speed at which technology is evolving today, like year and a half ago, I was building products on GPT 2.53, and today GPT 3.5, 4.5 Turbo, and Gemini Cloud, Anthropic, so many models came really, really fast, right? In like a span of a year.
Right.
It's the kind of speed at which technology is evolving, right? We want students who at least showcase a potential to have a very strong grasping power.
Okay. So I have to have mathematics for sure.
Yes.
So because this is a confusion that might arise in a lot of students' minds. Can I be from commerce with maths or humanities with maths?
You need to be from science with maths.
I need to be from science. So basically, I do need to be from science, have mathematics, and be able to then make sure that I'm doing at least a minimum of 60% in maths.
Absolutely.
Ideally, do better than 60%, please,
Yeah.
everybody. Right? and be able to do that, I'll then give an entrance exam.
Yeah. So
You will
to
then
give you
introduce
some
different
mathematics,
aspects
some
there.
statistics, out of every 100 students who give our entrance exams, probably 10 to 15 pass to
Okay.
the next stage. So
Okay.
next stage we have 2 rounds of interviews. Now, who are
Right.
the
Okay.
interviewers, right?
Right. Okay.
So one is a like a mathematical round again, like it's more like live problem solving with the interviewer and the mentor. And second is a dreams and aspiration. Now, who are the interviewers? All the interviewers are alumni of Scalar who are working at a Microsoft, Amazon, Google, from top tier companies. Now, why do we have these folks as interviewers, right? So that they are able to gauge the child's intent, potential, and thinking ability, right? Who better than a doctor to evaluate a potential doctor's potential, right?
Fair
Something like
point.
that.
All right. So I have an entrance. I come from science. I have to have maths. I do an entrance. I do 2 rounds of interviews.
Yes.
And any group discussions or anything like that
No,
that have
no.
to be
Two
done?
rounds of
No.
interviews. Sometimes if you are exceptional, then it's 1 round of interview for you.
Got
Uh,
it.
and
Okay.
then based on that, you can essentially clear the exam and then you get an admission offer from us.
Right. Okay. Perfect. So options for scholarships or things like that
Yes.
available for students?
Yes. So we have two type of scholarships. One is uh, Brightest Mind Scholarship. This is essentially given to students who demonstrate exceptional performance either in can be in two of the 5 parameters, right? One is your entrance exam and set. Second is interviews. Third is any other competitive examination like a JEE or a BITSAT or anything else you have given, right? Fourth is your 10th and 12th, because we know that especially in computer science, your past historical performance can be a reasonable indicator on how you will be able to cope up with the program, right? And then we also look at your achievements across extracurriculars, like have you been in sports, have you built your own projects. Last
Perfect.
year we had 60 plus students who left IIT, NIT, international top institution seats to come and join us. 30% of our batch already was proficient in coding. That means, I mean, 70% wasn't. So if you're not proficient in coding, it's okay, you will come and learn with us.
Okay. So perfect. So if I have taken a JE exam or a BITSAT exam, will you accept that score instead of
No,
your own
no,
entrance?
no.
So I'll still give your entrance exam.
Absolutely.
Lovely. That clarifies a lot for me. I am from either a Cambridge board or an IB board. Am I still eligible to apply to your
Yes,
institute?
yes, you are applied. You can apply.
Great. The approach to mathematics is very different. Like that's a question that's in the chat, which is a very valid question. They're a Cambridge student or even an international baccalaureate student. Their mathematics approach is very different in terms of how you're learning. So the entrance exam takes that into
Takes
account
that
and
into
things like that.
consideration. I think it's more about, again, like our focus is not on like I would say a state board mathematics, right? Rather, that's the most counterintuitive where you learn by heart the formulas and you then have your scored on steps, right? That's a very
Yeah,
different
yeah,
way of looking at it. The way our exam is designed, it's to genuinely think, can you do mathematical thinking? Can you think math? Can you understand how that formula is built?
got it. Okay, perfect. We're almost at closing. Let me just look and see if there are any questions that you can help answer. Um, So you are definitely looking at, I like the fact that you're looking at extracurricular and co-curricular, which
Yeah,
is
yeah,
very
we value
important.
that a lot. If you have done any hackathons, if you have built your own startup, if you have built
Lovely.
your own business, anything which even social work, right? We value all these things a lot.
And students are getting exposure to things like, being able to do well in the workplace with internships, but in terms of
Absolutely.
communication skills and things like that as well. Wonderful. Where can people go to be able to find out more about your fee structure?
Absolutely. I can share, you all can go to our website. Uh,
So everybody who's interested in looking at that, they're just going to pop that in the chat. So you can go and have a look at the fee structure.
yes.
So any specific post-graduation input that somebody can do after a computer science degree, or is the world sort of wide
So
open in
best
terms
part
of
is,
what
right,
can be done?
in our 4 years, right, we assist you in enrolling in the BITS ka BSc Computer Science. So BITS Pilani's BSc Computer Science, parallelly is what you pursue. We assist you in the admission process of the same, and also a MSc in Computer Science from Wolf University. So that Wolf University is an accredited university in UK. So now
Yeah,
what it does is, when you graduate in 4 years, you already have a BSc plus MSc, which completes a 16-year criteria. And in further, if you want to go to US or UK, anywhere for your further studied just for migration, like that's what most people do, right? So your some of your credits also can be transferred and you will be seen as a favorable candidate because you already have
interesting,
an international qualification.
interesting. All right, great, that's wonderful. Um, Any last minute advice or last closing words, things you wish you knew before you got into the degree? You wish you knew this in school and you want to be able to pass the knowledge on. So Naman, things you wish you knew that you would like to give advice to students on.
Yeah, I think maybe I think I wish I knew at that particular time how democratic, how proof of work oriented software engineering as a domain is, right? I think if you ever have felt an excitement towards innovation, an excitement towards building things, an excitement towards having to find a solution of a problem, right? Something irks you and you're like, how to solve that particular thing. Probably computer science, software engineering is the domain that can give you that. But when you enter this domain, don't enter this domain just for money. Okay.
Yeah.
That very counterintuitively, the more you enter for the money, the lesser in terms of money you will be at. Maybe you will be able to make good money, but not that great money. There are people who make great amount of money in software engineering just because they're doing for the fun of it, solving the problems that people have. If you solve the problems that people have, it gets you a lot of money, it gets you a lot of validation, it gets you a lot of popularity, right? So just do that particular thing. Software engineering is probably the most welcoming field, whatever domain, whatever background you are coming from. What matters is what you can do, is what you can build. And even if you don't want to do a job, probably one of the most important, best fields probably to do freelancing, to build your own companies, etc., etc. So definitely, probably you have considered a great field, but do join that not for the money, but for the excitement of building things that it
For
can
the
give.
joy of it. Yeah.
It's correct.
Yeah. No, I completely agree with you. I think it's important to chase the excellence element. The money comes if you're excellent at what you're doing. That's true. Yash, your last minute advice?
I think a couple of things, right? When I look back at my journey so far, right? Like one thing is be a contrarian and get it right, right?
Mm.
Like so, if everyone is doing X, if you have conviction on Y, but just because everyone is doing X, you move towards X. I would highly recommend you to do Y and just get it right. Show up, do it consistently, show discipline, and like get better 1% or one step at a time every day, right? And that can take you a long way. Like in my case, uh, like leaving my lucrative job opportunities after a London Business School or IIM Calcutta, or even like and building my own company, raising close to $1 million and selling it off. I think that contrarian decision played out really, really well for me. It's just 10x more effort.
Yeah, it is. All things require effort if we want to work at
Absolutely.
them. If someone's not done really well in 10th, they can and improved as they've gone along. You're still going to look
Yeah,
at
yeah,
them
yeah.
in terms
So
of
we look
looking.
at 1260 is the criteria.
12th and 60 is the criteria. All right. Somebody asked that question. I appreciate your taking the time to speak to us today to be able to clarify my doubts. I know I learned a great deal. Thank you for helping me be able to learn more, to be able to help students better. Everybody, please feel free to be able to check out the institute. Did you pop the link into the chat? Yeah, Yash.
Yeah, 1 second.
Yeah, just hang on a second. We're putting the link in the chat so you're able to go
There
see.
you
There
go.
you are. You have the link for the institute. You can go in and check out the admission criteria again, information on all the information on fees, structure, scholarships, etc. All of that will be there. Thank you for taking the time, both of you. All the best to you both. Thank you.
Thank you.
And we appreciate you coming to speak to us and to speak to the students. Ishti, over to you.
Thank you so much, Mr. Yash and Mr. Naman, for taking your time and having this webinar with us. Thank you, Shilpa ma'am, for asking those questions to help the students get a better understanding. I hope everybody who joined the webinar was very informative to you. And please, go on the website and explore as much as you can. And before we end the webinar, just a parting note, keep connected, stay connected with Mindler. You can always reach out to us for any career related query, any guidance at hello@mindler.com. Or you can also follow us on Facebook, Instagram, YouTube, wherever you want, wherever you social media platform you are, to stay connected, know more about these webinars. Thank you so much for joining in today. Thanks a lot.
Thank you, everyone. Good night. Thank you.